My name is Dr. Mike Vasquez. I'm going to talk today about the printed athlete, so how 3D printing and its various forms are being implemented in sports and what the actual future for that is. So basically to start, I just wanted to tell you guys a little bit about myself and how I approach the kind of whole sports and analytics and engineering thing. So I consider myself a sports technology engineer or a sports technologist. So what that means is basically I help athletes maximize their performance through performance and safety through engineering. So that entails designing better products, better apparel, thinking about the perception of all these things and how they kind of come together through engineering principles and science principles. So I am an MIT alum. I studied materials engineering, and along the way, I also played baseball. I've been a baseball nut all my life and love all sports, but baseball was my passion, and actually played at MIT. And surprisingly, they do have a baseball team. I was a pitcher there, and kind of during my career there, a friend of mine on the team, actually a shortstop, came across the Sports Innovation Lab at MIT. It was a collaboration with the Aeroastro department, and what it entailed was basically companies from industry, so different sports design products, so New Balance, Rawlings, kind of came to MIT with short projects for students to kind of engage on, put some smart people to work on these projects that might be further down the road of what's coming out next. So I got involved with a few projects with Rawlings, designing different catcher's gear and looking at bat performance for them, and just loved it. Fell in love with actually applying engineering principles to sports equipment and decided to make that my passion. So that's how I kind of come towards the sports industry. And from that, I actually spent the last 3 years at a place called the Sports Technology Institute in Loughborough, England. So Loughborough is about an hour north of London, and it's a very small town. I'm sure not many of you have heard of it, but in England, it's considered kind of the hub of sports for the country. So especially with the Olympics this year, it housed the base camp for Team GB, and it was a lot of, it's kind of known for having great facilities, so the pools, the tracks, and everything for training is kind of all centralized there, and because the country isn't that big, a lot of the athletes kind of come there. And they've teamed that up with a Sports Technology Institute, which is a 2 to 3 story building focused on kind of improving the athlete experience through science and engineering. And that includes robots that'll shoot golf clubs, they'll kick soccer balls, we'll even do bra testing for people who would be interested in kind of learning about that to improve the experience there. So I spent the last 3 years doing a PhD there, and I was working specifically with 3D printing and with a company called Burton Snowboards. I'll talk a little bit more about that in detail later on my talk, but I just want to kind of give you an overview of some of the kind of things that I come from my background and how it kind of implements into sports. And specifically, I'm a materials engineer, so I like thinking about what new materials are on the horizon, how can you implement those. And we even did a short project for Wimbledon a few years ago where, I don't know if anyone's been to Wimbledon, but when a big part of the experience is standing in line for tickets. So every day before the matches begin, there'll be lines of people that will kind of sit for hours, waiting for a ticket. And in this process, like they're usually just staring at nothing. But for Wimbledon, we designed a whole kind of panel of wall space designed to look at what the future of technology and materials would be for tennis in the next 150 years. So it was to go along with the anniversary of Wimbledon, and it was a pretty interesting experience. So now I'll get to 3D printing. And kind of the colloquial term for that is kind of additive manufacturing. So building things layer by layer, or kind of layer-based manufacturing. So there's a lot of different types of 3D printing or additive manufacturing machines, and they all kind of have the basic principles in mind. So the idea is you take a 3D model, so something you design in a CAD-like software system, and imagine like a shoe or some sort of kind of three-dimensional kind of object. And when you have this model in your computer or whatever, you can put it to a printer, much like you would do if you had a Word document and were just sending it to your HP desktop printer. So the idea is basically rather than just printing ink on a kind of a 2D paper, or 3D paper, but you get an image. So let's go with the shoe example. You slice it into very small layers, so about 100, 150 micron layers. That's kind of about the size of a human hair or a couple human hairs. And each layer is then printed on in this machine through a variety of means. So depending on the type of consolidation that's going on, each 3D printing process has a different name. So there's things such as fused deposition modeling, laser sintering that uses a laser to bind the different layers. And a lot of the kind of interesting machines that are getting a lot of kind of mainstream media hype are things like the MakerBot, where these are kind of desktop machines that you'd be able to buy for about $2,000 to $3,000 and have it in your home. So that's kind of a general overview of it. Where it comes into sports is in a variety of ways. So I'm going to kind of pick out 3 or 4 examples of how 3D printing and various technologies have been implemented into sports and athletics. And the first is with wheelchair basketball. So wheelchair basketball was developed by World War II veterans, and it's one of the most popular Paralympic sports. And the interesting thing about it is that athletes of all kind of functionality and range of motion can play it. So even able-bodied athletes are allowed to play wheelchair basketball, provided that each person is scored based on how much or how little physical function that they have. So a player with full physical function, so no real disabilities, is given a 4.5, and if you don't have as much physical functionality, you're going to 1. So each team has the ability to kind of have, I think, 14 points total of players on the court at any given time. So the issue is with people or kind of athletes that have certain functionality limitations is a lot of times the standard or kind of off-the-shelf wheelchair frame isn't up to their liking, especially if they're trying to perform at a high level at the Olympic level. So trying to develop a one-size-fits-all chair for them doesn't really work. And we worked at Loughborough University with the GB team, and what we were trying to do is try to design customized wheelchair frames for them, or wheelchair seats, so that they would then not be able to, or have a better idea of kind of not moving around as much. They could kind of move and kind of turn and rotate and shoot without being uncomfortable or kind of hindering their performance in any ways. So one of the athletes, I'll just kind of pick out one that we worked with and share his story, but it was generally, we kind of did, this project was done with several of the athletes over the time. And this particular athlete had kind of a certain biomechanical limitation where when he sat down, his hip placement was a lot more narrow than kind of an able-bodied athlete. So when he would sit in a normal chair, he'd kind of move around quite a bit. So the process that we went through with him was actually doing some 3D scanning of him sitting in a variety of positions. So not just kind of sitting in a chair like you guys are now, but also how he would sit if he was shooting a ball, passing a ball, and trying to maximize kind of his shape for each different motion. So what we were then able to do is take this 3D scanning data and create a 3D model. So once you have the model, that's where the 3D printing can then come into play. And the project resulted in the creation of several customized wheelchair frames or wheelchair seats that then the athlete was able to use and test in a real world performance. So the material's strong enough to actually get kind of beat around, people fall, it's pretty common in the basketball game, and like where there were no issues and cracks or anything like that. So as you can see, I think it's tough, a little tough to see, but like the outer frame, the rigid shell is 3D printed and customized to the athlete with a soft kind of foam-like covering to go around it. So it was a nice project to kind of showcase how you can kind of do these bespoke creations using the technology, and then kind of the end result was the GB team used several of these chairs and ended up being in I think the bronze medal game for the Paralympics. And now I'll talk a little bit more, kind of that's one example, and Where I did a lot of my most recent work was with a company called Burton Snowboards, and they're a snowboarding company, obviously. They're based in Burlington, Vermont, so not too far from here. And they're one of probably the leaders, if not kind of in the most recent time, the leader in almost any industry for pushing the boundaries of 3D printing. So this is their lab. So there's a couple of 3D printers here. If you can, so this is one here. It's called a laser sintering machine, and this is another one, an objet machine. But two different types of processes, but they use the 3D printing machines for functional snowboard bindings. So what I mean by that is stuff that you can actually take on the mountain and do crazy jumps like this. That's not me, but I've been on some of these 3D printed bindings and feel totally comfortable and totally safe. So the nice thing about that is, rather than kind of going through if you know anything about kind of injection molding or kind of molding in general, to try and prototype things very quickly, it usually gets costly, and you have to send it to outside manufacturers to get it done and then the ship back. So it's a time-wasting process, especially if you have the ability to do customized one-off or five-off design changes in a short amount of time. So what we were working on was 3D printed bindings. There's several parts of the binding. So this is called a high back, and this is what actually attaches to the board. And all these components actually were 3D printed, and using a process called laser sintering, where a polymer material, a plastic material that comes in a powdered form, looks kind of like table salt, rather than kind of the consolidation mechanisms is a laser. So every layer is melted at the given cross section, and then as it cools, you get a hardened part that's kind of the consistency of a hard plastic. So the plastic is nylon 12, but is pretty rigid and pretty strong. And these bindings were actually developed to withstand all sorts of interesting, kind of the elements that you would experience when snowboarding. So it's cold weather, it's moisture, like people are going off jumps that might not be kind of typical loading situations like in other applications. So it was really pushing the boundary and trying to maintain high performance while maintaining safety. So comparing to kind of a standard board binding that was manufactured using conventional means, it held up pretty well. And these would last entire seasons and with no failures or anything like that. So it was designed as a prototype, so not end manufacturing, but it was more to kind of help the engineers iterate really quickly. And overall, kind of this is just kind of a slide to give an example of some other materials. So kind of just making a general case about 3D printing is that it's still pretty early on, and the technology has been around for about 20 years or so, but like starting to get in mainstream now. But a real limitation is the materials and materials design. So the processes are really good at delivering parts with like hard functionality. So something like a fireman's helmet. So think of that consistency of material. But if you wanted to start doing other sports things like shoe soles or protective padding or padding that goes in a helmet or something like that, it's not quite getting there. So what I spent a lot of my time with Burton on was developing new materials for that process. So things that are more foam-like and would be more kind of applicable to sports and sporting type applications. But I don't know if anyone was in the keynote today, but 3D printing is kind of one of those unique things where a lot of the technology learnings, because it's such a unique environment, has actually transferred into other industries. So they're really pushing the envelope for the technology generally into other things. So, and then just some other examples of the process. Formula One racing teams use it to prototype small models of their cars and of parts so that they can wind tunnel test them. And Nike, this actually just came out this week, they were using 3D printing, similar process to what Burton was using the bindings to develop customized football spikes. So they were using them on athletes at the combine that were specifically designed for the 40. So to kind of increase your 40 time, and by having these customized spikes where not only could you kind of customize where the spikes were on the shoe, but you could optimize for what material, like how, like are they running on turf, are they running on grass? So you could really kind of optimize that and fit it to each person, and not doing the idea of having 3D printing. Kind of, I think everyone as I talk, you get ideas of what could you do with this. So like the first one is obviously in medical devices. That's a nice application where you're able to kind of, along the same lines of creating the customized wheelchairs, you're able to scan different people's body parts and for implants, for injury prevention, and even injury recovery. So having a 3D printer in the operating room or kind of close to the operating room, we're able to kind of image a person before they go into surgery and kind of help with the creation of implants or tissue scaffolds for the patient. So not only is plastic a viable material for 3D printing, but also metals, so things like titanium and stainless steel that are also being applied to 3D printing in a pretty wide scale as well. So, and then personalization. So that's something, rather than having elite athletes kind of thinking along that line, is kind of the future would be to you and I go into a footwear store, we get our foot 3D scanned. There's already companies kind of doing this for general fit, but if you're able to then kind of turn around and have a 3D model right away of what your shoe or what your foot looks like, then you can kind of customize it for not only performance but also fashion and kind of a customizable feel to it. So, and then just enabling kind of customized training and performance, and that goes along kind of the same lines with the wheelchair example. We worked with another Paralympic athlete who had difficulty squeezing. So he was a tennis player, and the way his hand was, I think he had an injury previously, and he was a tennis player, but he couldn't use a tennis racket kind of the way he used to, and actually had to duct tape his hand around the racket handle every time he went out to play. So with the technology, we kind of scanned his individual hand and built a part that it could just snap onto a tennis racket and then fit his hand nice and smoothly, and he could grip down kind of to his limitation and then play relatively normally. So that's kind of an overview of 3D printing and some of the applications in sports. I just wanted to touch on some of the things that are going on in the industry and spark some questions. So I'll leave it kind of the last bit of time for that, but I'll leave this up there if anyone has interest. And then I also kind of on the side, since I'm always interested in new things coming out for sports and engineering. About 2 years ago, I started something called the Sports Technology Podcast, where we interview we've probably gone 40 or 50 interviews with people doing interesting things with entrepreneurship, engineering, research in sports and technology. So if you guys are interested, we've talked to a bunch of people there, and some on 3D printing and some on a variety of other things. So with that, I'll leave it open for questions. Yep.
I'm looking for a value add.
Excuse me, I've got.
Looking for a good value in a scanner. I have a 3D printer.
Okay.
What have you found out there that's, because a lot of the 3D printers are coming way down in price.
Yep.
The hobbyist ones, obviously, we've got a dimension, but what's a good scanner, good price?
It depends on what you're going to do with it. I think maybe
Just
we can talk.
Education.
Oh, education.
Just get them using it, getting them integrating the two technologies.
Yeah, I think on the order of several hundred, like a few.
Really? Okay, that's good.
I
appreciate it. And you mentioned the sintered materials. The sintered metals are then fused afterwards? Is that how it's done?
No, that comes out of the machine ready to go.
It does, wow.
Yeah, usually it comes on a plate, like you'll have a base.
And it's some percentage of the tensile strength of the patent material?
It's pretty close with metals.
Really?
Yeah.
Wow. Thank you.
The example of going into a footwear store and getting your personally made shoes, can you say anything about the scope of it? 2 years, 5 years, any idea?
Probably closer to 5 years. I think the materials are still being worked on, but I think the processes for doing everything up to the printing is there already. So just kind of deciding on what material you'll build it on, and then kind of thinking about the actual operations side of that, the supply chain, and where do you have to get these printed and things like that. So.
Are there any other questions? All right, Mike, thanks a lot. Let's give him a big round of applause.